Welcome to all. Today, question 49. Before we start anything, those who are serious, first make a note here. Don't say anything now. One small note you write. So far, for inclined plane, what all I tell you should write. We consider just one body or one block. See, all the questions so far. Now you are going for questions for two connected bodies. See here, two connected bodies placed on an inclined plane. Okay, once you put this one, you have to go to question 49. Okay, now once you write this heading, go to question 49. Okay, see, question 49 here, I am rubbing everything. Two blocks 1 and 2 of weights 600 Newton and 800 Newton connected by a cable, single sentence. That is, the two blocks are connected by a cable are resting on a rough inclined plane which makes an angle of 40 degrees with horizontal. See, this is the rough inclined plane. With horizontal, the plane is making 40 degrees. Block 1 and block 2. They told block 1, see, understood, see, 8 Newton, you can write here, respectively. Actually not required. Respectively, okay. Means block 1 weight is 600, block 2 weight is 800 Newton. Connected by a cable, okay. And little later I told, see, coefficient of friction for contact surfaces of block 1 and block 2 are, for block 1, mu 1, I will take 1, mu 1, 0.2. For block 2, it is 0.25. Now, one doubt will come. Whether block 1 is upper side or block 2 is upper side. Depending on that one, answer will change. Therefore, I wrote here, see, block 1 is above block 2. So, block 1 is upper side, block 2, you can write block 1 is above block 2. Above is not this way above, height wise above. Or you can write block 1 is upper side, block 2 is lower side. Okay, now what they want is, the person who set the question, he thought this system is not stable. He thought, actually I only thought, I know it. When I tell the person who set means, I am not taking responsibility. Because sometime I give a question for which negative answer will come. So you cannot tell, sir, how you can think that way? When you solve a question, somebody gave the question, me only question, okay. Me only gave the question, okay. No. He thought that this system will slide down. It is not in stable equilibrium, means it will not be at rest. So, what he wants is, find what least force along the plane, see, this way, along the plane, is required to be applied to block 1. See, to be applied to block 1 to prevent the system of blocks from sliding down. He wants this system of blocks not to slide down, means, see, he is asking you what force is required to prevent. 100% it is like this. See, it can't be like this. Okay, now, that is for block 1. If the same question, next class I will solve. Question is, if the force is to be applied to block 2, then it will be like this. See, like this. See, when it slides down, here you apply a pull, but here you apply a push. See, when suppose something placed on inclined plane, if it slides down, upper side you apply a pull, lower side to prevent it, you apply a push. Suppose a vehicle is parked here, inclined plane. You observe that it is going to slide down. What to do? You either come to this, see, you either come, see, if you feel it is going to slide down, you come here and apply a push to prevent. Or if you think it is sliding down here, you go that side and apply a pull. That is common sense. somebody in the road will understand the statement. Okay, now, so here they want the force to be applied to block 1. So 100% that force is like this. So I will not write here now. This is the force. See. So therefore, this is the force. Say P. They want to apply. Least value you want means I told thousands of times. Least value of P means the system is on the verge of sliding down. This all you know it already. Okay, now you write the question, put the sketch, see, 0.2, 0.25, cable, don't show tension or P you mark, you write here, one place you write here, let P be the least force to be applied along the plane. Next class question, I will take an inclined force. Okay, next time. Along the plane, least force to prevent the system of blocks from sliding down the plane. Down the plane, you write that way. Common sense will tell you upper block you have to apply like this. Okay, that is clear. Now, okay, right here, you write the question before we start solving the question. See, this much you write. Then you write a note here. See, before you start solving the question or any question, now connected bodies, what you are write is, see right here, see, on an inclined plane, see, inclined plane this way, when you connect by this way, if you apply a pull, see, if you apply a pull this way, then this will be in tension. Common sense, see, when it slides down this way, when you apply this way, this will be in tension. So, if it is in tension means, see, how? I told already this way. In tension. T. You take it as T. Now, this can be either a cable which is actually flexible. That is, cable means what? Cable means fully flexible. See, cable is fully flexible. Or it can be a rod. That is somewhat rigid. You make a note. This already I told earlier. See, when something is in tension, see here, tension, it can be a solid member, a rod, or it can be a rod. Where is the cable here? Some cable was here lying. It's there. Here, see. Okay, something is there. See. Or it can be a cable. Either cable or what? They can tell either cable or rope or sometimes small weight, even wire or string, which can take tension or can be rigid rod, because tension means, see, I told already, this all I told you earlier. See, tension means cable will do, flexible member will do, and rigid member also will do. Right here, after this one. Either apply force that way, or if you apply force this way also. Write it. You write the sketch, then write, but when you connect the two members, place this way, suppose you are applying a force like this, or from that side, or like this. These are pushing forces. When this you require to prevent from sliding, that you require, or this is required what? Either to prevent from sliding or move the system up the plane. This is to move the system down the plane. In such cases, it cannot be cable. It cannot be cable. Because then this connecting member will be in compression. See? This also I told you. See? When you apply a push this way, see, when the force is this way, or then this member will be in compression. I told already, see, this will be in compression. In compression. Say, see, now cable is ruled out. They cannot give a cable. Question is nonsense. If a member is in compression, see, when it comes sliding down, or if you push this way, the cable will fold. See here, the cable will fold. See, if I take here, see, if I apply a pull, cable can take. If I apply a push, where is the cable? Now it should be a rod. Now it cannot be a cable. Cable not possible. It should be a rod or some solid member, not flexible member. So this I already told. Make one more note. Every class in the question I cannot tell. I will tell you, refer to the first. Actually, this I told you long back when I solved questions on two connected bodies in horizontal plane. I already explained this one. But still I am telling once again. So this time you are applying a pulling force. It is a cable. Yes, see, if you connect by a cable, you can pull it. Or imagine a vehicle is tied to another vehicle using a rope or cable. If you go to the upper vehicle, start and go further, that vehicle will follow the cable in tension. But if you go in the reverse order, it will fold the cable. This vehicle will go and hit the other vehicle. See, cable cannot take compression. So remember, when push comes or compression comes, it should be a solid member or rigid member, a rod, anything. But when tension comes, it can be either cable or a rod. So remember, rod or solid member is okay for both tension and compression. But cable you can give, cable or wire or string or rope, those things you can connect only when that member, that rope or cable should be in tension. It should not be in compression. Okay. This all I told you. You write all this note and now start solving. Okay. If you want one thing, write here. Let P be the least force, I told you, this way. And one more statement you write. See here. P already told. Let T be tension in the cable. Tension in cable. Then further statement. Let all I write here. Let R1 and R2 be, you write, normal reactions for block 1 and block 2. You should write it. Then we know that, one more statement, we know that least force required to prevent from sliding means the blocks are, the system is on the verge of sliding down. When the system is on the, see, the purpose of this P is to prevent the system from sliding down. So if you remove P, system will slide down. When system is sliding down, frictional force will be like this. Right here, frictional force will be along the plane in the upper side. It will go above upper side. This way. And also right here, since it is the least force, the system is on the verge of sliding. You write that one. On the verge of sliding, that frictional force FF will be FF limit equal to mu into R is the general equation. Therefore, you write here, FF limit for 1 will be what? mu1 into R1 equal to mu1. Where is mu1? 0.2 into R1. And also FF limit for 2 will be mu2 into R2. Your mu2 is 0.25 into R2. So later for this friction, see, the system is going to slide down. So we are preventing from sliding down. So friction is acting this way. For here friction, I will write 0.2 R1. This friction, I will write 0.25 R2. These all statement you write. Now what I am doing is, I wrote big letters today. I will remove the complete question and put a neat sketch here showing everything. Then I will solve. Sketch. This everything I am removing now. Complete board I am removing. Don't ask anything later. How you can ask when I am not in front of you? By comment also don't ask. Okay. I did not remove this sketch because I want to explain here. See. Now put a neat sketch here showing everything. See. 40 degrees, 40 degrees. Now this all over. See. Weight 800 down, weight 600 down. Normal reaction R1 perpendicular here, normal reaction R2. And I told you, since this mu is 0.2, friction FF limit for 1 is 0.2 R1. Since this mu is 0.25, FF limit is 0.25 R2. And I told you, tension in the cable is T. And P is the force you have to find. Sketch is systematically clear. And remember, next time onwards, I decided not to explain 0.25, that if you take R2, it is 0.25 R2. If you take R1, 0.25 R1, that all you have to write. If you expect me to tell every class same thing, you will be for a surprise. Okay. Now, this much clear. Now, this sketch I can remove. See, now, refer this one. See, what to do. See, correctly. How to solve. See, first, consider equilibrium of block. Which block? Doubt comes. Again, I told earlier, consider equilibrium of that block for which number of unknowns are lesser. See here, if I take block 1, see here, number of unknowns, you make a note here. For block 1, number of unknowns are R1, then P and T. See here, for block 1, R1, P, and this is not unknown because why? This is in terms of R1. Okay. Whereas, therefore, 3 unknowns. Only 2 equations. For block 2, unknowns are R2, then T. Oh, only 2 unknowns. This all you make a note. This I already told, I am wasting my time. So first block 1. Block, not 1. Which one? First block 2. Block 2. Write block 2 first. Block 2 first. Thoroughly explained. Explained. Therefore, write it. Write it as a reference. Don't, in the examination solve, you don't write that way. Write it for reference. Actually, if you are solving examination question, don't write. What you write? Consider equilibrium of block 2. Okay. Now, when you consider block 2, see here. This side I'll put here. Inclined plane. Block 2, this angle is 40 degrees. Block 2 is here. This all thoroughly explained for you. Now, let's see. I do one thing now. I will bring it down here so that no confusion. 40 degrees. Okay. Now, this weight is acting down. How much? 800 Newton. And this is the normal, see, 800. This is the normal reaction, R2, perpendicular to the plane, R2. And then there's a tension here along the plane T. And also, see, this arrow mark. For block 2, this arrow mark. For block 1, this arrow mark. This already told you, see, you divide. And also, there is a frictional force here of what? 0.25 R2. Now you need not waste time writing FF limit Y. All you explained here. See, everything explained here. 0.25 R2. Now do one thing. Write here. This is our reference XX. This I told thousands of times. XX here and YY here. YY here. Then, if this is 40 degrees, this is 50 degrees. And if this is directly along X, directly along X, directly along Y, these three, no resolution. For this one component like this. This all I told you earlier. One component like this. Well, this way. This is component along XX. Angle is with XX. This is cos. This is sine. Okay, now, right here. Sigma Fy0 take upward positive. Upward means this way positive. What you get? Plus R2, see, plus R2 minus 800 sine 50, 800 sine 50 equal to 0. This has, see, when you do along YY, this has no component, only R2. Therefore, you get the value of R2 in Newton. I have not solved the question. I am solving now. No, sorry, I suddenly thought the mic is not on. Oh, mic is on. Otherwise, once again at record. 800 into sine 50. See, by chance when I solve any question, if there is a calculation mistake, don't make issue of that one. Sine 50 is plus 612.836 Newton. 836 Newton. Correct answer divided by sine 50. Correct. Then next make sigma Fx0 take this side positive. See, this way positive. Plus T, our unknown is T. So write that unknown first. Plus T, no resolution. Plus 0.25 R2. See, plus T plus 0.25 R2. This has no component. Minus 800 cos 50 equal to 0. Now, substitute R2 equal to plus 612.836 Newton. Anybody having a calculator, you get the value of T. Therefore, T will come in Newton. Calculate T in Newton. It will always come plus. See, in by chance, if member is in compression and if you take cable, T will come negative. Question is nonsense. Why? Cable cannot be in compression. So, it is 0.25 into 612.836. 836 minus 800 into cos 50. 361.021. plus 361 point, okay, red color I use red color for T, because why? Because it is a tension, plus 361 point, not 21 Newton. Not 21, correct. Not 21 Newton. Correct answer? 800 into cos 50 minus 0.25 into 612.836 is, I'm getting some other answer. 800 into cos 50 minus 0.25 into 612.836 is 361 point, not 21 Newton. Okay. This is over. Okay, now do one thing. See, this will finish equilibrium of block 1. I want some space now. See, over. Now write here. Consider equilibrium of block 1. Equilibrium of block 1. This is block 2, equilibrium of block 1. Okay, start. Block 1. Show the sketch here. This is the inclined plane. I think it started raining now, but rain sound is okay, because why? Not much now. See, weight is acting down. How much? 600 Newton. Then a normal reaction here of, this is a, if you want, you can write here, this is your block 2, this is your block 1. A normal reaction here of R1, this is R2, correct. I wrote R2. Normal reaction R2. Then friction force here, see. This friction force is 0.25 R2. I will check the board once again, and see here. We are taking this one, not that one, sorry. Here you should see. See, weight 600. Okay, weight 600. Normal, oh, this is R1. See, I am seeing here. It is R1. What is this? See, I am seeing block 1. So, weight 600, R1, 0.25 R1, a force P along the plane. Next time I will put the inclined force. See, next time I will put the force this way. Then P also you have to resolve. That's all. Nothing to worry. And then very important, see, when I consider block 2, this tension will come. A tension force like this. See here. A tension like this along the plane. Tension T. Now you know the tension. How much it is? This is tension T, but you know the answer, 361 point, not 21 Newton. Not 1 Newton. Now, once again write here. This is your XX plane, XX. This is YY. YY, and if this is, how much? This is 40 degrees, means this angle is 50 degrees, not visible, 50 degrees. If you resolve here, this way and this way of cos and sine. Okay, since it is not, ink is not good, I will put black also. Usually green color I will put. Hope XX, YY is clear. XX and YY. Okay, now space is not there. For this one, I start from here. Sigma Fy0, take this way positive. That is, see, this positive. You get plus R1, see here, plus R1 minus 600 sin 50 equal to 0. Therefore, you get the value of R1. See, therefore, I write here now. Therefore, you get the value of R1. 1 minute, I lost R2. I just check the camera once. I think I have not gone beyond the limit. Okay, no beyond the limit. You get the value of R1. R1 will come 600 into sine 50. 459.627 plus 459.627 Newton is R1. Then sigma Fx0 take this way positive. See, that is this way positive. Now R1 is not there. See, when you do sigma y, first of all, already told, okay, plus P, that unknown force, plus P, see here, plus 0.25 R1, plus 0.25 R1, then minus this tension. Don't put tension, you write minus what? You know the answer. Now there is no T because you know the answer. Okay, do one thing, minus what? 361.021, make a note, this is that tension, see, plus P plus 0.25 R1 minus 361.021 all are along XX, this is not there, minus 600 cos of 50 equal to 0. Therefore, you get the value of P. With that one, this question is over in Newton. You get the value of P. What force is required just to prevent the system from sliding down? Anything wrong? Sine cos, okay. See, it is 600 into cos 50, answer, plus 361.021, then minus 0.25 into R, 459.627, 631.787 plus 631.787 Newton. I think it is correct. Okay, I don't want to make mistakes here. Minus 0.25 into R1 is 459.627 plus 361.021 plus 600 into cos 50. Yes, 631.787 is the force required just to prevent the system from sliding. This question is over. Today being Sunday, hectic activity for me. From morning I took around 4 hours class. Evening again some 4 hours class. Now it is well past midnight. Because I do not want to leave a day gap in between as much as possible. Every day I want to upload unless there is some problem. So today I will stop now. You go through this question thoroughly. Next class I will try to solve at least these connected bodies, not one question, minimum 2 or 3. Actually another or 2. Why? Another 5, total 5 questions are there. I decided around 5 questions. One master question over today. Next class 2 question, other class 2 question over. Then we will do questions on, see, double inclined this way. One block here, then connected by a cable. These are all important questions. Okay, that we will solve little later. So now, what all I told today, everything go through, understand, and get ready for next class. Okay, we'll meet in the next class. Thank you.